Alright, this is a review that covers what to do with exponent rules, covers scientific notation, talks about how to solve quadratic equations using square roots, and talks about how to simplify radicals. So that's a lot of things. It's kind of a long review, but here we go. On the first section that we're going to look at, our instructions are to simplify and that our answer should only contain positive exponents. This is a thing we do in math where we try to make all of our exponents positive because honestly, positive exponents make way more sense to us intuitively than negative exponents do. When I look at number 1 and I see r to the negative fourth, well, what does that even mean? Well, as a mathematician, I know that that means that I have an r to the fourth, but it's not really an r to the fourth on the top of this, if you want to think of it like a fraction. It's actually r to the fourth on the bottom of our fraction. So it does mean something. It just makes more sense when we have positive exponents. The way we would work out number 1 is we take the normal numbers 2 and 2, and they're being multiplied together because of this multiplication sign in the middle. So we do 2 times 2, which is 4. And then we say, what is r to the negative fourth and r squared if I put them together? And the way this works is because they're being multiplied together, we add their exponents. It's easier to see that whenever we have two positives that we're multiplying together. That if I have r squared and r cubed, I have r to the fifth, because here is r times r, and here's r times r times r. So really there's 5 r's being multiplied together. It's a little bit trickier when you have negative exponents, but the same rule applies, that I'm adding them together, which gives me r to the negative 2. To finish this, we take the r and we move it down to the bottom, and our act of doing that is what makes the exponent turn to a positive. A negative exponent on top is like having the same thing, but with a positive exponent on the bottom. Notice that the 4 got to stay on top. The 4 has its own exponent of 1. It does not have an exponent of negative 2. So that 4 to the positive 1 gets to stay on top because it gets to stay on top because it already had a positive exponent. Another rule that we have on number 2 is the rule that if I have a power to a power, what I do is I multiply those numbers together. So this is k to the 12th. And this is another thing that we're using this rule to give us a shortcut, but we could work this out by saying I have k to the third, but I have it 4 times. We could write it out like so. And then if we used our previous rule about adding exponents, we add all these together and we get 12. Or we could go a step further and write out all of the k's and count up all of the k's, but that would be a lot of effort. So, and that, yeah, k was a poor choice of variable. Anyway, 3 times 4 is 12, so it's k to the 12th. Our third rule on number 3 is if we have something on top and something on bottom that they're the same base letter, we subtract their exponents. So I would do 4 minus 2, which is 2. The reason for that is because what we're doing is saying I have a 4 times on top and I have a 2 times on bottom. And so 2 of the a's on the top and the bottom cancel each other out, and I'm left with 2. And that process we're going through is basically like we're subtracting how many a's we have. So that's why we subtract their exponents. And then the rest of these kind of combine some rules or do some different things with our rules. So some of them get a little bit complicated, and almost all of them have more than one approach that we can take to get the right answer. So I will show you at least one way, and it may be that you did it a different way and get the right answer. And so as long as you get the right answer, you probably did it a correct way. It's not likely that you just lucked into the right answer. Happens sometimes, but not as often as we'd like. So on number 4, we've got a negative, and we can think of this like there's a 1 and this is a negative 1. We want to do negative 1 times negative 1 and get positive 1. That means that the negatives in front of x and y are going away. The x and the y don't get to go together and combine into one thing because they're different letters. All we can do at this point is say that x needs to move down to the bottom so that it has a positive exponent of positive 1. And then we don't need to write it down. If you do, that's fine, but we don't have to write it down because it's x to the first, which we know is just x. right, so number 5 is an example where this is us actually not really combining rules, it's actually expanding on the power to a power rule. If there's more than one thing inside our parentheses, everything gets the power on the outside, kind of like we're distributing the power. So that means that the -2 gets the third power. The m to the 4th gets to the third power, which makes it multiply and get 12. N to the -3rd gets the third power, which gives us -9. So it's important to remember -2 had its own exponent, and now we're giving it an exponent of 3. And if I do -2 cubed, it's 8, and it's negative because we have 3 negatives. So an odd number of negatives gives us a negative number overall. The other thing we can do is move this down to the bottom, the n, so that it has a positive exponent. We could do that in the same step or separate steps. So this should be our answer. Again, m and n are different, so they don't combine into one letter. Number 6. For whatever reason, it seems to be the numbers that trip people up more than the actual variables themselves. If there's a 2 on top and a 2 on bottom, we know that 2 over 2 is 1. And it doesn't matter that there's y's involved, it's still 1. And then we would look at our y's and subtract their exponents. And so we would say, what is 1 minus -2, which is really y plus 2, which is 3. So when I subtract exponents, I put the result on top, and then I check to see if I need to move it. So it's y to the 3rd, which is a positive exponent, so it gets to stay. On 7, there's 2 different ways that I think of to do this. One is to go ahead and distribute the -1 exponent. The other is to say, well, if all of this is to the -1, I could move this whole thing down to the bottom right off the bat. And what that would do is that would give this on bottom, everything inside stays the same for now. We move it down to the bottom, and that gives it a positive 1. And since it's a 1, it doesn't change anything inside of our parentheses because it's 2 to the 1, x to the 4th, and y to the 4th still. And then we would say, okay, now I can cancel these 2's out. I can subtract my exponents, so that I get x to the -1 and y to the -2, which means I need to move those down to the bottom. That's one way to do it. The other way is to say, let me distribute this -1 to everything in my parentheses. Let me change colors to do it this different way. And so we'd still have 2x cubed y squared, but now we've got 2 to the -1, x to the -4, y to the -4. And so we would add our exponents, like this is 2 to the 1st and 2 to the -1st, which together makes 2 to the 0, which goes away. X to the 3rd and x to the -4th, we add those together and get x to the -1. 2 and -4 makes -2. And that puts us in the same place we were right here, where we move down to the bottom. So whichever way you want to work that out is totally fine. And there may be a secret third option as well that we could use. Number 8. We want to take this 4th power and give it to everything on top, not what's on bottom, because the bottom's not in parentheses. So it's 2 to the 4th, x to the 16th, y to the 8th over y. 2 to the 4th is 2 multiplied together 4 times, which is 16. The x doesn't have anything to combine with, but I can subtract the exponents for my y's, remembering that the bottom is y to the 1st. So that gives me y to the 7th. On number 9, something that we haven't talked about yet in this video is what the 0 power means. M to the 0 is 1. Anything to the 0 is 1. And that has to do with the fact that, like, we could add our exponents here, m to the 4th and m to the 0, and it'd still be 4. So that's not affecting anything. That's why it cancels out and is just 1. The other thing that cancels is the 4's, a 4 on top and 4 on bottom. So now what we have is m squared, m to the 4th, n squared, and n cubed. I just rewrote that just to get rid of the extra information to make it easier to see. So then we would subtract our exponents for m. and add our exponents for n because the n's are next to each other, so they add and stay on bottom. This m needs to move down to the bottom so that it's 1 over m squared n to the 5th. Number 10. Negative x to the 4th power is one of the first things we need to do. And we have to pay attention to this negative. I have what's basically a negative 1 being raised to the 4th power, and I have to think, what does that mean? If I multiply negative 1 together 4 times, is that going to be a positive result or a negative result? It's a positive because there are an even number of negatives, so they all cancel each other out. So that makes the bottom of this be x to the 16th. The top, I can combine those x's and get negative 3. So we could do this a couple ways. We can subtract our exponents and then move down to the bottom, or I could go ahead and move this down to the bottom and then add my exponents. What we should get is 2 over x to the 19th. So whichever way you want to think about that is fine. Everything on top needs a squared, everything on bottom needs a negative 1. Or with the negative 1 on bottom, we could move the whole thing up to the top to give the entire parentheses on the outside a positive exponent. That does not change the exponents inside, by the way. Moving the whole parentheses made this exponent change. To make the exponents inside change, we would have to keep going. But right now, they're still either positive or negative based on what they were on bottom. So we could do that. We could give everything in here as squared. A negative squared is a positive. Then we'd have b to the 4th and 2 squared, a to the 4th, b to the 6th. We don't need this exponent anymore since it's just 1. And now we can combine our numbers together. We can combine our a's together. And we can combine our b's together. So here's 2 squared and 2 is 2 times 2 times 2, which is 8. A to the 4th and a cubed are a to the 7th. B to the 4th, b to the 6th, and b to the negative 1 is 10 minus 1, which is 9. But you also could have distributed the negative 1 exponent on bottom and then worked on it from there. And you get the same thing. Now we're moving on to scientific notation. So for scientific notation, the way I remember this is that if I have a really small number, like on number 12, really small meaning a decimal, something smaller than 1, then that means I'm going to have a negative exponent. I want to figure out how many places it takes to move my decimal so that my number's between 1 and 10. In this case, I'm shooting for 5. I moved the decimal 4 places, but I moved it, but because it was a small number, it has a negative exponent. Because when we are writing this, we're literally saying 5 times 0.0001, because that has 4 decimal places. If we were to put a positive exponent, we'd be saying 5 times 1, 2, 3, 4, 5 times 10,000. Which of these actually gives us what we started with? This one right here. Okay, so that's why we use a negative exponent for small numbers. We use a positive exponent for big numbers. So I have to count. I'm aiming for between 3 and 7, which is 5 places. So it's 3.7 times 10 to the 5th. Now let's go the other way. So again, positive exponent means big number, so let's move to the right 4 places. That means I need 3 zeros, which gives me 36,000. 15 is a negative exponent, and so that means that I move to the left. So there's only 1 0 between the decimal and the 4s, so 0.044. Now we can do some operations with scientific notation. We can multiply by saying what is 5 times 9, which is 45, and then by using our exponent rules to put the tens together. So since this is multiplication, they would add. and get negative 5. This is not proper scientific notation because we want to have numbers between 1 and 10. So we need to fix this. Instead of 45, what I want is 4.5. So I would write 4.5. Then I need to decide, does that make the exponent go up or down? And so here's a way to remember it. We added a decimal, so we need to add to our exponent. This didn't have a decimal. We made it have one decimal, so we need to add 1 and get negative 4. On 17, our shortcut is to divide these numbers and then subtract these exponents. That may require us to come over here to the side and do some division. This is 6 times and 4 left over, or well, we bring down the 4 and then it goes in once and no remainder. So the first part of this is 0.61. We're going to subtract our exponents. 1 minus 4 is negative 3. This is not a number between 1 and 10, so we want to move our decimal place over. We're losing a decimal place. There are 2 decimals here, now there's only 1, so we subtract from our exponent. Okay, we took away a decimal, so we take away from the exponent. Now on 18, when it's to a power, we give everything inside a power. So 6 squared times 10 to the 8th. 6 squared is 36, which is bigger than 10, so we need to make this 3.6. We added a decimal, so we're going to add an exponent, add to our exponent. And that is scientific notation. Now we're solving our equations by taking square roots. So we want to solve for x squared, or in this case x squared is already solved for. So we want to think about what is the square root of each side. The square root of x squared is x. The square root of 0 is just 0. When we're doing these equations, we normally have plus or minus signs, except in this case, because plus and minus 0 technically doesn't make sense. We only have one thing for 0, which is neither negative nor positive. So we just say x equals 0. This is the only case, other than no solution, where we would not need a plus and minus sign. On the rest of these, we're going to have to do a little work before we square root. Like here, I need to subtract 2. And then I need to say, well, what is the square root of 74? It's plus or minus. I need to think about the fact that 74 is even, means 2 should go into it. And then do some division here real quick and figure out the other factor is 37. Both of those are prime. They're not perfect square factors. So I can't simplify the square root of 74, so I leave it as a equals plus and minus square root of 74, which may not seem like a very satisfying answer to you, but it is what it is. 21, we need to divide by 3. And we get 25. We'll square root both sides so that b is positive and negative the square root of 25, which is 5. 22, subtract the 10. And these steps I'm doing are just like what we did with linear equations, by the way. So we want r squared by itself, and we treat it the same way we would a normal equation. It's at this point where we have r squared by itself that we do an extra step where we square root. Not only is it important for us to remember the plus or minus sign here, it's important for us to remember that we do know the square root of 1, which is 1. So we would not leave it under the square root. We want to simplify it to just 1. (23). This is a problem you may know the answer to just from looking at it, but when it's an equation, you should probably do some work just to make sure you're right. So we add 4 and get negative 77. We divide by 5. And what matters here at this point is not what negative 77 over 5 is. What matters is that we're trying to square root a negative number. There are no real square roots of negative numbers. So this is no solution. Now, if you're in Algebra 2 and you happen to be watching this video, you know that there are some imaginary solutions to this. But as far as Algebra 1 goes, or as far as it may depend on your teacher. Like, it may be that this is a no solution situation. If you know about imaginary solutions, you'd want to put the imaginary solution. So on 24, we need to subtract 7. Get 120, divide by 6, and get 20. Square root both sides, and what we get is positive and negative. We need to simplify 20. It doesn't have its own square root, but it is made up of something that we can square root. I don't know why I did that. Square root of 20 is square root of 5 times square root of 4. We know the square root of 4 is 2. So the square root of 20 simplifies into 2 square roots of 5 with a plus and minus. The rest of these are just simplifying square roots, like what we just did on 24. So like 63, I'm looking for a perfect square factor like 9. So I'm splitting 63 up into the square root of 9 and the square root of 7, and saying I know the square root of 9 is 3, I don't know what the square root of 7 is, so I leave it under the square root. And that is our answer. So here on 26, what goes into 150? That's a perfect square. Or if we are having problems figuring it out, we would make a factor tree. And if we do make a factor tree, the idea is that we're saying, okay, I've got square root of 3 and square root of 2, but these 5s can go together and be square root of 25, which means that this is what I can square root and bring outside of my radical. So that I would end up with 5 square roots of 6, but I've got this negative 5 in front, making this negative 25 square roots of 6. On 27 and 28, I personally prefer to multiply first. What is 3 times 8? It's 24, and then do my thing where I try to find a perfect square factor, and I get 2 square roots of 6. 20 and 15, again, I would multiply together and get 300. This one's a little more obvious than 150 was about what we can divide into it. 103. So the square root of 100 is 10. Square root of 3 is square root of 3. And then these last two are fractions. So what's important is that we can simplify things that are both under the radical or things that are both outside. We could rewrite this as square root of 5 and square root of 3 on top, square root of 4 and square root of 5 on bottom, and cancel out our square roots of 5. And then on bottom, square root of 4 is 2. So those cancel. You also could do it differently. You could just simplify square root of 20 on bottom to start off and get this. The 2's cancel, and then we'd still be stuck simplifying 15 and 5 to get 3 under the square root. But either way, we should get the square root of 3 as our answer. And then finally, on 30, the bottom, we can take the square root of and get 3. The 9, square root of 9 is 3. So we have 5 times 3 on bottom, which is 15. I cannot simplify the 10 and the 15 because one's inside and one's outside. So that is my answer. And that is this review. Happy studying.